parallel process management. So here we will learn what is a process, the definition for the process, what are the different states that a process undergoes during its execution in the system. Then we will study the process state diagram, and importantly we will learn about process control block. In short, we say PCB. In early computer systems, which are uniprocessor systems, they had only one processor. So here the user will be executing only one program at a time, and this program will be having access to all the system resources. What are the system resources available? They are CPU time, memory, files and I/O devices. So all these resources were allocated to the user at a time to accomplish his task. But in contrast, in today's computer systems, they allow multiple users to access the system, and at the same time multiple programs will be running in the system. So in memory, many programs will be loaded and they are executed concurrently, simultaneously, and this results in the program being called as a process. So what is the definition for process? Process means a program in execution. So the different steps in execution of a program is, first it has to enter the system, it should be stored in the memory, made it ready for execution, then execution should be carried out. A program in execution is called a process. Although the main concern of operating system is the execution of user programs, in addition to this, the operating system will do certain other tasks behind. So operating system, along with the execution of the program, it has to take care of various system tasks that are left outside the kernel. A system therefore consists of collection of processes. Operating system processes executing the system code as well as user code. All these processes can execute concurrently with the CPU being multiplexed among them. So CPU is made to share between the processes. They can be either user code or the system code. So by switching the CPU between processes, the operating system is made efficient one and it is utilized productively and efficiently. Now coming to process in detail, let us learn what it contains. What is a process? What are the contents of the process? So as we know, process is a program in execution, but the process along with the program code, now this program code is called as text section. Our program code will become text section. Along with that, we have the program counter PC. PC is the program counter which will keep track of the next instruction to be executed, and along with these two informations, it also stores the information about the CPU registers. What are the registers that are available and what it contains, those informations are also stored in the process. So a process, generally it includes the process stack. So along with text area, then the contents of CPU register, along with that we have stack also. So what this stack, what it contains? It contains temporary data such as parameters that we are going to pass to some functions, then the return address from the subroutine or from the function, and also the local variables information. So they are all included in the stack. Then we have data section. Data section contains the global variables which are common for the main program as well as for the functions. So a process, along with these informations, it stores one more information called heap. Heap is nothing but a memory, a group of memory which is allocated to the data or to the program which is undergoing, whose execution is undergoing, and here the allocation is done dynamically. So if we are allocating memory to a process dynamically, then what is the other way of allocation? It is static allocation. Static allocation means allocating the memory to the program during compilation time. Dynamic allocation means allocating memory to the program during execution time. In figure, you can see the structure of a process in memory, what it contains. So initially it has text area. Text area involves the program code. Then data area, it will represent the global variables which are referred by both the main program and the functions which are involved in the execution of that particular program. Then we have heap. As I said earlier, heap is nothing but group of memory which we allocate to the program during execution. Then stack contains the information about what are the functions to which the program referred and what is the return address from the function to the program and what are the local variables used during execution of that function, all those things. Then PC means program counter register. It is a CPU register which keeps track of the execution of next instruction, and the contents of CPU registers during execution of the process, it is also stored in the structure of the process. See, now we can compare a program with a process. Program and process, they are two different entities. A program is said to be a passive entity, whereas a process is active entity. Why a program is passive entity means it is just a file containing list of instructions stored on some storage devices, say disk. So it is in executable form, whereas process is an active entity with a program counter specifying the next instruction to be executed along with set of associated resources. So a passive entity, that is program, it becomes a process when we load the executable file into the memory. There are two common techniques of loading the executable file into the memory. In that, the first one is double clicking an icon representing the executable file. The second technique of loading executable file into the memory is by entering the name of the executable file on the command prompt in the command line, like filename.exe or program.exe or say a.out. So explicitly we type the name of the executable file in the command line. Say for example, you have single user system with Microsoft Windows operating system. Say there are several users who are running the web browser. So a user will come, he will run the web browser to the same system, another user will enter, he will run the web browser. So like that, multiple times the web browser will be executed in the same system, but still the text section will be common for all, whereas data, heap and stack sections will vary from user to user. Now let us know about the different states of process to which it undergoes during execution in the system. As a process executes, it changes its state from the ready state till the terminate state. The process is defined by its different states. At a time, in which state it is, based on that we say it is in the current activity. Each process may be in one of the following states. Say first one, new. The process, once when we create, it will enter automatically to the new state. Next state is ready. So when the process is waiting for execution in the queue and it is waiting for the processor to be assigned to it for its execution, then we say it is in ready state. The next state is running state. So we have created a process, so it enters new state, ready for execution, so it is in ready state. Next, when processor is allocated to the process, then it enters running state. So here instructions are being executed. And suppose during execution of instructions, there may be some IO instructions, input output instructions, which are waiting for input or for output devices, or say they are waiting for some event to occur in the system. During that time, the process will enter the wait state. Once the IO is over, that is once the input is given or output is sent to the output device, or once the event is completed, then the process resumes execution by entering to the new state, that is ready state. So after wait, it should go back to ready state. Say the execution of all the instructions is over, then the process has finished its execution and now the process will be in terminated state. So now note that at a time, at any instant of time, only one process will go to the run state, not all. Even though in the system more than one process are executing concurrently, among them only one process will be in the running state. Then what about other processes? They will be either in the ready state or in the wait state. The next information stored in PCB is the information about CPU registers. The registers, they vary in the number and also in the type of registers, and then how many number of registers are there, it depends on the architecture of the computer. But generally it includes accumulator. Accumulator, when we use this type of register, when we are doing some arithmetic operations, say you want to add two variable values, store it in some other value like a plus b equals c. Here, to store the result, it uses accumulator. So the other arithmetic operations we perform are subtraction, division, multiplication. Next we have index registers. When do we use index registers? When we are using arrays. It may be one-dimensional array or two-dimensional array. When we use the array concept to keep track of the cells in the two-dimensional array or to keep track of the elements of one-dimensional array, we use index register. As we know, we have stack pointer. The next stack pointer, what is the task of stack pointer register? It will be pointing to the top of the stack. Other than these specific registers, we have general purpose registers also, which will store the data temporarily. And along with these general purpose registers, specific purpose registers, we have some other registers called flag registers, which will store the condition values, like is the stack empty. So for that we can have one flag. or is the array empty. So for that we can have another flag register. So along with these things we have program counter, which is also a CPU register. So these registers together, they will give the information about whether the process is in running state or in any other state. And say while execution some interrupt occurs. So during that time the current state of the process will be stored in the PCB, process control block, and then the execution of that interrupt is continued. Once the interrupt execution is over, then the processor will resume the execution of this process by seeing the information in the PCB. So the next information stored in the PCB is about CPU scheduling, meaning the CPU has to be shared among all the processors. So in order to do that, several algorithms are executed, CPU scheduling algorithms. How to choose a process from the queue and allocate CPU to it. So that is followed by certain algorithms. These things we will study in the coming chapters. So CPU scheduling information includes the process priority and the pointers to scheduling queues and to any other scheduling parameters. Next, it includes the information about memory management, meaning when we are allocating main memory to the process, we will be addressing those locations by different ways, by giving the absolute address, that is the direct address, or we may address it by giving certain relative values, meaning just giving the base address from where the program starts, give the base address. Then how many instructions are there, that count we may give, meaning start the execution from this address, then counting the number of instructions. Once the count is over, the program execution will be stopped. So that is another way of executing. So there we give the value of the base register, which stores the base address of the program, and then the limit register value we have to give. Then if we are following paging or if we are following segmentation method for allocation of main memory to the process, then this memory management information will store the information about the page tables and the segmentation tables. So it depends on which type of memory management we are doing in that particular system. Again, memory management will be studied in the coming chapters. So the next and the final information stored in the PCB is accounting information. So like the operating system, it will keep an account of how many resources are used by this process and how much it has allocated from which time to which time. All those accounts are stored in the accounting information. Then I/O status information. This information includes the list of the I/O devices allocated to the process and also how many files are opened during the execution of that process. That information is stored in I/O status information. Now let us study. As we know, in one system more than one process are residing and more than one process they will be executing. Then how do the process come to know which process is requiring which resource? So for that we have the switching of CPU from one process to another process. How it works, that you can see in the diagram. Suppose we have two processes which are running concurrently in the system, and we let us say we label them as process P0 and P1. Two processes P0 and P1 running concurrently. How this concurrent execution is managed by the CPU. Say certain instructions of P0 are loaded first, so meaning now P0 will be in the execution state, running state, and suppose in the middle it may require some IO operations. So during that time CPU will be switched from P0 to P1. So when P0 was running, P1 was in idle state. So when CPU is switching from P0 to P1, in PCB of P0 process, that is process control block of P0 process, the current status values are stored, and then the CPU will switch to PCB of P1 process, and it will retrieve the information of all the register values, and it continues executing the process P1. And say after certain instructions execution of P1 will be in some wait state. It may be waiting for some IO or for some event to occur. So again, now CPU will switch to P0 by saving the current status of P1 in PCB of P1, and then getting back the information from the PCB of P0 and resuming the execution of P0. That is how CPU switches between one process with the another process. So when an operating system, when it is interacting with a process, the interface between them is provided by the system calls. These calls, they are generally available as assembly language instructions, and they are provided in the manuals of assembly language program. But some systems, they allow system calls to be made directly from high level language program, in which case these calls, they normally resemble the predefined function call or subroutine call, meaning in high level language program these system calls, they act like normal function call or normal subroutine call. So the high level language programs, they generate a call to a specific runtime routine that will make the system call, or the system call may be generated directly by the high level language instruction. For example, in high level language, say C, and in Perl, here instead of the system call, they will be executing a system program, that is a routine will be executed. These languages, they allow system calls to be made directly. C and Perl, they implement the direct system call access as well as direct system program access. And most Fortran systems, they provide the similar capabilities with a set of library routines. So in order to study the communication between process and the operating system, which is through the system call, for that let us consider one example. Say you are writing a simple program to read data from one file and to copy it to another file. The first input that the program will need is the name of the two files. One file is input file and another one is output file. The program needs the name of these two files. These names can be specified in many ways depending on the design of the operating system. One approach is for the program to ask the user the name of these two files in an interactive way. So here a sequence of system calls are required. First is to write a prompting message on the screen and then to read from the keyboard. So it has to first ask for the name of the file and the user has to give the input from the keyboard and then the file names are defined. Another approach used to specify the name of the files is in the previous batch systems, the names of the files were specified with control statements without interacting with the user. Say you are given two file names, input file and output file names, in any way, either in interactive way or using control statements. So once the two file names are obtained, the program must open the input file and it should create the output file. Remember, it should open the input file, but output file must be created by the process. So each of these operations, they require another system call. There are also possible that some error conditions will occur for these operations. When the program tries to open the input file, it may find that there is no file of that name, or it may find that the file is protected from accessing it. So in these cases, the program, it should print a message on the console. So to print a message, again another system call will be activated. So while accessing the input file or while opening an input file, when an error occurs, then the program should print a message on the console. So for that, it will execute certain system call and then it will terminate the execution abnormally. So again, for abnormal termination, another system call will be initiated. Suppose the input file exists, then we must create a new output file to store the output. So while creating the output file, we may find that there is already an output file with the same name. So in this situation, the program should abort the execution by generating one system call. Say since already we have one output file with the same name, then we may delete the existing file. Again, to delete the existing file, another system call will be initiated. After deleting the existing file, we have to create new output file. For that also, one more system call will be initiated. So all these operations are done by generating system calls. Say while creating the output file, if already we have a file with the same name, then we have to remove it and we have to create the new one. That is one option. Or another option is it is available in the interactive system. So here the operating system will ask the user whether to replace the contents of the existing file or to abort the execution of the program. So now assume that in system we are ready to read the input file and also the system is ready to create the output file. So both the files are set up. Now we enter a loop which reads the input file. So again, to read the input file, one system call will be initiated. Then to write to the output file. So it will be executed in a loop, reading the file, writing to the output file. Each read and write, it must return status information regarding various possible error conditions. So now the possible errors while reading and while writing are, say on input, the program may find that the end of the file has been reached. It is EOF, end of file. So if that is not encountered properly, it will generate one error, or that there is some hardware failure in the read operation. So for that we have parity error. So these errors, they occur in terms of input. But while write operation, the errors may be depending on the output device. If it is writing the file to the disk, it may encounter no more disk space. So for that error, it should generate the proper system call. Or suppose now we are not using the magnetic tapes. Initially, when magnetic tapes were used to write the file, during that time the system may encounter the physical end of the tape. So for that type of error, it should generate one system call. If the file is written to the printer directly and say the paper is not fed to the printer, then printer will be out of paper. So for that error, a particular system call will be generated. So finally, when all the files are copied to the storage, or all the files are copied to the printer, the program may close both the files. Meaning input operation is over, output operation is over. So now the program has to close both the files. For that, one more system call will be generated. To give this information to the user, the system will write a message to the console. Again, to write a message to the console, one more system call. Finally, since it is terminating the program execution normally, it will generate one more and the last system call. So as we can see, these programs, they make use of operating system heavily. So as we know, the program and the system, they communicate with each other through system calls, and we have several system calls. Now we will categorize them to 5 main categories. Say process control, file manipulation, device manipulation, information maintenance, and communication. First come to the first category, that is process control system calls. So related to process, the system calls that are generated are end, abort, then load, execute. Coming to end and abort, say a program is running, so it needs to execute, and the execution should come to an end, either normal end or abnormal end. Normal end is nothing but end, so for that end system call will be generated. If there is any error, then the program, it terminates abnormally. For that, abort system call will be initiated. Then we have load, execute. A process or job executing will want to load some other data or some other program. So for that we have load system call. Next we have create process, terminate process system calls. There is a system call specifying for the purpose of creating new job or for creating new process. We may want to terminate a job or terminate a process. So for that we have terminate process system call. So the next group of system calls which come under the same category are get process attributes, set process attributes. That is, if we create a new process, we should be able to control its execution, and the controlling of the execution is through the system calls which will be obtaining the process attributes. So to get the process attributes, get process attribute system call will be generated. And say we want to reset the attributes, then for that we have set process attributes. When a process enters wait state, then the system call generated is wait time. So like wait time, we have wait event and signal event. So the process may wait for some other event to occur. So for that time, wait event system call is initiated. Or the process may wait for some other signal, then signal event system call will be initiated. So in file manipulation category, we have the system calls which are related to file. So what are the operations we do on a file? We will create a file. Once created, we will open it for input purpose, or we may do read or write operation. Once the operation is over, we are closing the file, or we may delete the file. So related to that, first create file, delete file system calls. They will make the operating system to create the file and delete the file. These two system calls, they require the name of the file and along with that some of its attributes in order to identify which file to create, which file to delete. So once a file is created, open the file. For that, open file system call. Once the task is over, to close the file, close file system call will be initiated when such files are no longer in use. What are the operations performed on a created file? Read, write, repositioning the file. So for these three, again we have system calls. In order to get the file attributes and to set the file attributes, we have get file attribute, set file attribute, system calls. Set file system call, it will reset the attributes of the file. The next category of system calls, they come under device management. So as the name itself indicates, these system calls are related to storage devices which will be in action during the execution of the program. So related to this, the system calls are request device. When we are storing it, the output in some device, requesting for it, and then releasing the device. Once the function is over, once the task is over, releasing the device. And again, here related to the device, we have read, write, reposition. Once the device is requested and if the CPU allocates that device to the program, then read operation, write operation and repositioning of the device will be performed. So coming to information maintenance group of system calls. Here the system calls are get time data, set time data, or get date, current date, set date. So these are done through system calls. So using these system calls, the current date time are set or obtained. Then we have get system data, set system data, meaning at that particular instance of time, what are the informations available related to the status of the system, they are obtained by using get system data. Whereas the status of the system will be set to the user convenient by using set system data. So it returns the information like the number of users who are all using at that particular instant of time, the operating system, then what is the version of the operating system, how much memory is available at that particular instance of time. So these informations will be obtained by get system data system call. Next we have get process attributes, set process attributes. So here the operating system, it will keep track of the informations about all the processes which have entered the system, which are ready in the queue for execution, and which are executing in the system, and how many processes have been terminated. All those are kept track by get process attributes and set process attributes system call. The last category of system calls is about communication. So here the user may communicate with another user in the same system. So that is by creating the communication connection. Once the communication is over, then that communication connection will be deleted by one more system call. After setting up the connection between the users, the first user may send the message to the second user. The second user will receive the message again through system calls. And transfer of status information is also possible using these system calls. And say once the communication is over, we can detach the device. So attaching of the device, detaching of device is done through communication system calls. So as we know, process will enter different states during the execution in the system. So we have come across wait state. So when will this program enters wait state? When it needs certain IO operations to be performed or some signals or events to occur. So in this middle, we say an interrupt occurs in the system and the process will enter the wait state. So now what is an interrupt? So during execution of interrupt also, the program or the process will enter wait state. What is meant by interrupt? So an interrupt is an external signal which is external to the program. It will be from a device. The device may be either input device or output device which is attached to the system, and the interrupt may be from another program. What it will do? It will be requesting the operating system to stop the execution of the process and attend it with high priority. So once an interrupt signal is sensed, the system will stop the execution of the current program and it will take up the service of the interrupt, and once the interrupt service is completed, it resumes the execution of the process. Dear students, with this we have come to the end of this chapter. I hope you have learned about what is a process, what are the different stages that a process undergoes in the system, and what is meant by process control block, why it is used, then what is a system call, what are the different categories of system calls. So I hope that you have understood all these things in this class, and thank you.